Hey guys, today I'm going to go over trigonometry. I'm just going to go over as much as stuff in trigonometry as I can because that's what we've just started in Algebra 2 trigonometry. Okay, let's go. Let's do it. I'm going to start from like as basic as I can get, which is the word itself. Word itself. Trigonometry, which is the study of triangles, specifically right triangles, like this one that I just drew. And you can deduce what the lengths of the sides will be in a right triangle based on any given angle in said right triangle. This is because right triangles follow the ratio of the Pythagorean theorem, which is a squared plus b squared equals c squared. So that's why trigonometry is mostly based around right triangles, because of this Pythagorean theorem and all the ratios that come with it. Also, it's important in like architecture. If there's like a triangular frame in a building, you want to like do that. Also, vector quantities in physics and like reflection and refraction and stuff. And I'm just drawing lines right now. But trigonometry is very important, very important. And there are 6 functions that come along with trigonometry. And those correspond with the sides. You got an angle in a right triangle. So it's a right triangle, so you know you got to have a hypotenuse side. It's a hypotenuse, hype. And then there are 2 other angles which make up the legs. There's the one that's next to the angle, which is called the adjacent side, because it's adjacent, it's next to it. And then there's the opposite side, which is the side that's opposite. So it's not, so those are the 3 sides. Those are how things are classified. And so a fraction is one thing over another. So it's basically as many different, all the trigonometric functions are basically as many different ways as you can combine these things together. So let's write. I'm gonna write them all down. Sine, sine of angle, cosine of angle, tangent of angle. Why won't this focus? There we go. Cotangent of angle, secant of angle, cosecant of angle. And there we go. So the sine of the angle equals opposite over hypotenuse. So it's this over this. Cosine is adjacent over hypotenuse, which is this over this. Tangent is opposite over adjacent, which is this over this. And then cotangent is adjacent over opposite. Secant is hypotenuse over adjacent, and cosequent is hypotenuse over opposite. And those are the 6 different ratios you can make out of the sides of a right triangle. And these are the functions. Really useful thing, really useful way to remember is SOHCAHTOA. That's just an acronym you can remember. SOHCAHTOA. Because sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. SOHCAHTOA. You can remember that. And you may be thinking, well, what about these? Don't these matter at all? They do, they do. But there's a trick to remember these. In fact, okay, all right. So sine, cosine, tangent, cotangent, secant, cosecant. So you only have the SOHCAHTOA acronym to memorize the first 3, but the other 3 can be remembered somewhat easily too. I'm just writing down the same things. So just imagine like a mirror mirror right here. And you're done. You got it. Because if you look at the ratios, they're reciprocals of each other, or like reflections. You look at tangent, opposite over adjacent, cotangent, adjacent over opposite. Secant, hypotenuse over adjacent, is reflection of cosine, adjacent over hypotenuse. So it's an exact mirror. It's an exact reflection. This can be tricky. This can be good to remember because secant is a reflection of cosine, and cosecant is a reflection of sine. So the co-whatevers don't go with each other. Sine goes with cosecant. Cosine goes with secant. It's not cosine with cosecant. It doesn't work that way. You can get pretty easily tricked by that because it's just like, oh, they're cos, they go together. No, that's a trick. Yeah. And these are the reflections. Cotangent is just 1 over tangent. Secant is just 1 over cosine. And cosecant is just 1 over sine. Because they're reciprocals, they're reflections. If you look on your graphing calculator, actually, you see that it's only got sine, cosine, and tangent. Because that's all you need. You could just do 1 over this, or 1 over this, or 1 over this to get the other 3. Because you only need sine, cosine, and tangent to do the thing. Don't do sine of -1. That's not what you think it is. It's actually arc sine, and the way that works is if you take the sine of something, arc sine of like opposite over hypotenuse, and you'll get oh wait, no, that's if you do arc sine of sine of something, you'll get that something. It's like it's the inverse of sine. That's what sine in the -1 stands for. I know you would think it's like 1 over sine, but it's not. That's not what the notation means in that case. And that's just how mathematicians have written it. I didn't choose to make it that way. I don't think it's a great idea either. It's too late. It's too late, man. It's already been invented. Let's go down because there's more to remember here. There's more things that you can remember here. Sine and cosine. Sorry, I'm writing these out again. Because there's an important thing about tangent that you can also remember. What happens if you just say, oh, what's sine over cosine? It's O over H over A over H. Well, you're dividing a fraction by a fraction. So I could just take this bottom one and like flip it over and turn it into a multiplication problem. And then you got this, and then you could just cancel out the h's, and you get O over A. So if I actually put the fractions, focus, please focus. Okay, if I get the fraction sine over cosine, if I put those fractions in a fraction, I actually get simplified O over A. I actually get tangent. So tangent is actually equal to sine over cosine. Boom. And then cotangent, we know because of the mirror rule, it's just a reflection of tangent. So it's cosine over sine. And then we already learned the tricky thing with the secants, like how secant responds to cosine and cosecant responds to sine. So you got sine, you got cosine, you got sine over cosine, you got cosine over sine, you got 1 over cosine, 1 over sine. So really, actually, you only need sine and cosine to figure out all of them. And that's why sine and cosine are so important, because they're the key to everything. In fact, if you really think about it, if you can think about it this way, it's actually like courtesy that they're putting a tangent button here, because you really only need sine and cosine to figure out everything about all of the functions. So, yeah. That is all about all of the trigonometric identities you need to know. There are a lot of trigonometric identities. Oh, and by the way, like how like sine over cosine equals tangent, and how like secant equals 1 over cosine. Those are called trigonometric identities. Just call them trig identities because they're how sine and cosine and secant and cosecant, they just involve how they relate to each other. They're identities, you know. They define what those functions are. Now, I'm going to go into some little shortcuts you can do. I don't know how many of you remember the 30, 60, 90 triangle. And the 45, 45, 90 triangle. The 30, 60, 90 and the 45, 45, 90, they all have specific ratios. So 45, 45, 90 is 1, 1, square root 2. So this side will be square root 2 times both of these, where these would just be 1. I think this one is square root 3, 1, 2. So this would be times 1 of whatever. This would be times root 3 of this side, and this would be times 2 of this side. You can use these because you know the ratios of the sides. You don't need to know the exact quantities of the sides always to figure out sine and cosine and tangent and cotangent because they're ratios. So all you need to know is the relative ratios, and you know that in the 30, 60, 90 and the 45, 45, 90. So sine is opposite over hypotenuse, so that can work in this case. So let's take sine of 30. You could just take 30 in this example. The opposite side in this case is square root of 3. The hypotenuse is 2. So sine of 30 is root 3 over 2. Sine of 45 is, let's see, you take a 45 here. Opposite side is 1. Hypotenuse side is 2. Sine of 45 is 1 times root 2. 60 is, well, if you take 60, the opposite side is 1. The hypotenuse side is 2, so it's 1 over 2. So these are little shortcuts. And you can do this for cosine. You can do this for tangent. It's not just for sine. Sine is just an example. In fact, later on, when you look at the unit circle, you'll find that I think pretty much most of the difficult identities you have to remember involve 30, 45, and 60. Because these are the angles in those triangles that we all know about, that we all recognize the ratios in. Now, I'm going to go into radians. I really love talking about radians because the Common Core loves to just shove down your throat about why radians, about radians existing, and doesn't tell you about why radians exist. So this is a really badly drawn circle. And this is an okay radius. I'm going to draw an angle now. So this is an angle in a circle. Imagine an angle in a circle. Now, every angle has an arc length. What? Focus. Okay. Every angle has an arc length. I'm going to label this arc length L. And we know the radius of the circle is R. The idea behind this, you're like, why are you doing this, Aaron? The idea behind this is that every arc creates a length. Every arc in a circle, based on that radius, based on how long those things are, creates a length. Now, I want you to imagine another circle where the angle is 360 degrees all the way across. So you can't really see it because I can't draw a thing on top of a thing, but it's a 360 degree angle. And the radius is denoted as R. So what's this length? What's this length equal to if it goes all the way around? It's just the focus. It's just the circumference of the circle. And the circumference is 2 pi r. It's an old formula that we all know. And you're like, okay, Aaron, where is this all leading? Radians, which are alternate to degrees, are denoted by the ratio of the length created by an arc to the radius that the arc is. So if you're like, I don't know, I guess if you're like deploying radio waves or Doppler waves on a Doppler radar or something, you're trying to detect somebody and you want to figure out what range or like what distance that signal covers, and you want to know how far out you have to send those radio waves to get a certain distance length. Well, that's what radians are sort of for. It's linking this arc distance that this angle makes to the radius of the angle. That's what radians are. It's the ratio of that. So if you have a circle, the radians in this case would be 2 pi r, because it's a 360 degree angle. It's an angle all the way around, over the arc length, which is the radius, which is r, as always, and that comes out to 2 pi. So when you got a 360 degree angle, the arc length goes all the way. The arc length goes all the way around to have the circumference divided by the radius is 2 pi. So a full circle, 360 degrees, is equal to 2 pi radians. So 180 degrees is equal to 1 pi, or just pi radians. So radians are more important, or are mathematically better. Like, I'm not going to lie, I'm used to degrees too, because that's what we all grew up with. But it's the ratio of that length to the radius. And that's why it's more mathematically efficient. If you want to convert degrees to radians, you multiply it by pi over 180. Because you're dividing it by 180 and subbing it out by multiplying it by pi. And that's because pi radians is equal to 180 degrees. Equals radians. And inversely, if you wanted to convert radians into degrees, you'd do radians times 180 over pi, because you're subbing out that pi for the 180 degrees. And that's it. That's all you have to know about radians and degrees. I think that's it. I think that's all there is to know. Remember these tricks, these mirror tricks, and everything that is in this thing. That's it. That's all. Thank you for watching.